seen previously that we can model functions as a function machine where we have an input and output. So f of x equals 3x minus 7. We can input a 2, x equals 2, which means we can replace this x with a 2 in our function and then do the calculation and we get an output. And we can have these input-output machines through more than one function. So here we have two functions, f of x and then g of x. And we can do an input through the first function f of x. So in this case here, if I put x equals 2 into x squared plus 1, we end up with an output of 5. And that output can then represent the input for the next function in line, which is in this case g of x. And we can substitute our 5 into the 2x minus 1, and we end up with an output of 9. And to do this combined function, we have the notation. Our notation is going to be the inside function. It's going to be our first function. And the outside function is going to be the next function, or the second function in line. And then we could do this input and output through each function individually. We can also express these new functions as a function themselves. So in this case here we have x squared inside, so our f of x is inside our red g of x. So we're going to put the blue f of x function inside a g of x function. So it looks like this. So when we do our substitution, we end up with 2x minus 1. Now instead of x, our input function, our input is a function itself, and we can input the function f, which is x squared plus 1. And what's often implied is we can rearrange this and simplify this expression. So we end up with 2x squared plus 2 minus 1, so we end up with plus 1. So we can calculate the g of f of 2 by first finding the f of 2, the inside first, and substituting into the g, which is the outside. So inside first, outside second. Or we can input directly into the combined function. In this case, we've expressed that combined function as 2x squared plus 1, which we got here algebraically.